A skeletal review by Melody Moore. The skeleton is one of the largest organs in the human body, and it constitutes up to approximately 15% of our total body weight. The human skeleton is formed out of 206 bones, which provide support and offers our body a proper shape. Above all, our skeleton works to deliver protection to different systems and organs present in the body. In this presentation, I will be sharing what I learned in my anatomy and physiology lab this week. Anatomists divide all of our bones into two locations, the axial and the appendicular. The axial skeleton includes 80 bones, and it's divided into the skull, the vertebral column, and thoracic cage regions. They provide skeletal support and protection. The appendicular skeleton, are the bones that help us move around, like our limbs and shoulder blades up here and our pelvis. Now, there are 5 types of bone classifications and function. We have long bones, short, flat, irregular, and sesamoid. Long bones are longer than they are wide. These are the bones that provide support, strength, and mobility. The top half of our body rests upon our femurs, which is our long leg bone. And those femurs are so thick and strong, and it's because our body is resting upon it. Our tibia and fibula are also leg bones and long bones. Our humerus, ulna, and radius are all arm bones, and those are also long bones. The metacarpals and carpals are long bones as well. Short bones include the cube-shaped components of the wrist and ankle joints, and they include the carpals and the tarsals, as you can see in these pictures. And these bones help us grip and hold things right, and they allow us to have fine motor skills. Flat bones. They protect internal organs such as the brain, heart, and lungs, and they include the cranial bones, the sternum, and the scapula. Irregular bones, they vary in shape and structure, and they include our 33 bones in the vertebral column, and our pelvic bones, and our facial bones. Sesamoid bones, they develop in areas where there's some tendons in locations where there's a lot of friction, tension, and physical stress. We only have one type of sesamoid bone in a normal human body, and we call that the patella or our kneecap. We have 2 of those. We have, all of the bones have a similar internal structure. They all have a dense, smooth-looking external layer of compact or cortical bone over a porous, honeycombed-looking area of spongy bone. Now, all of our new blood is made in that spongy bone part here. That contains our red bone marrow. We have 2 types of bone marrow. The yellow bone marrow is where energy is stored as fat, and that is stored in the medullary here cavity, right in the middle of our long bones. We also have anticular cartilage on either end of our long bones to protect and lubricate joints. We have blood vessels inside of our bones as well that supply nutrients and remove waste. Now, there are 4 different types of cells in our bones. The osteocytes, they're mature bone cells that monitor and maintain your bone matrix. The osteoblasts, they help make bone. And the osteoclasts, they help to break down bone. The osteoblasts and osteoclasts, they create a perfect balance that allows our bones to regenerate. Now, we learned about 5 different types of bone breaks in our lab. One was an open or compound break where the bone pierces the skin. Then there's a closed or simple break, and that is when your bone breaks but does not pierce the skin. It breaks beneath your skin. A comminuted fracture, that's when our bone is crushed into 3 or more pieces. Sounds horrible. The green stick fracture is when we have a partial break in our bone that occurs as a result in bending. And an impacted fracture is when one end of the bone is driven into the other end. Now let's talk a little bit about bone repair. What I learned is that your bone bleeds, then it forms a blood clot, and then that becomes a hematoma. Then the osteoclasts, they remove the dead bone tissue. And the fibroblasts, they penetrate the area and build a callus that bridges over the broken bone. And then over many weeks, the osteoblasts transform the callus into bone. Let's talk a little bit about homeostasis. Our skeletal system is very important in maintaining homeostasis. It regulates blood calcium levels and produces the hormone osteocalcin, which regulates bone formation and protects against glucose intolerance and diabetes. It provides us with movement capability and supports and protects our soft tissues and harbors bone marrow. In conclusion, the skeletal system gives us the shape we have and the power to move. It supports and protects the internal body organs and acts as a storehouse for calcium. Bone is continually remodeled in response to stresses placed upon the body. Our 206 bones provide us with the way we look as humans, and they give us something for our muscles to cling to. Without bones, we would just be a big pile of jello. Thanks for listening.